You know that little sensor up by your rearview mirror? Ever wonder what it's actually doing? Well, turns out it's part of a huge revolution in car safety, one where your car is starting to pay as much attention to you as you do to the road. So let's dive into how this next-gen safety tech actually works. I mean, just think about it. What if you're on a long road trip, your eyes start to get a little heavy, and just before you even realize you're tired, your car gives you a gentle nudge? That's not science fiction anymore. It's exactly the problem this new wave of in-car AI is here to solve. So here's our roadmap for this explainer. We're going to start with the big picture, why your car is watching you in the first place. Then we'll zoom right in on the brain behind it all. We'll follow the data from the camera to a life-saving action, unpack the AI that makes it smart, and finally see how it's all built to be safe enough for the real world. Okay, first up, let's set the stage. The reason these systems are popping up everywhere isn't just because they're a cool new gadget. No, it's a direct response to the very real problem of distracted and drowsy driving. And there's a huge push from safety regulators all over the world to do something about it. That's right, big organizations like the New Car Assessment Program, you probably know it as NCAP, they're the ones who hand out those star safety ratings. Well, they're now baking these monitoring systems right into their scoring, so having this tech can literally make the difference in getting that coveted 5-star safety rating. So the first piece of this puzzle is called a driver monitoring system, or DMS. It's basically a little camera with a lot of brain power that's sole job is to watch the driver, to make sure your eyes are on the road and that you're focused on, actually driving. And the second piece of the puzzle is the Occupancy Monitoring System, or OMS. This one expands the view to the entire cabin. It's trying to figure out who or what is inside the car, so it can make other safety features like airbags and seatbelts a whole lot smarter. So what does this all look like in your car? Well, it means the car can tell if you're starting to doze off. It can see if everyone's buckled up or if there's a child seat in the back. It can even adjust how the airbags deploy based on how big a person is. And it's not all about emergencies. It can also just recognize you and automatically adjust your seat and mirrors. Pretty cool, right? All right, so we know what these systems do. Now for the fun part, how they do it. We're going to go from the concept to the core technology, and that brings us to this little powerhouse of a chip from Texas Instruments, the AM62A processor. Now, the AM62A is not like the chip in your laptop. It's what's called a heterogeneous processor. That's just a fancy way of saying it's a team of specialists all living on one tiny piece of silicon. Each part of the chip has a very specific job to do, and they're all optimized to work together for camera-based AI. Think of it like a highly efficient command center. You've got the ARM Cortex-A53 cores. They're the general manager running the main show. Then you have the C7X/MMA. That's the AI genius, just blazing through all the heavy-duty deep learning math. The VPAC is your image expert, taking all the raw data from the camera and getting it ready. And maybe most importantly, you have the ARM Cortex-R5F. That's the safety supervisor, making absolutely sure the critical stuff never, ever fails. Okay, so we've met the team. Now let's follow the data and see how this chip takes a simple picture from a camera and turns it into a real, meaningful, and potentially life-saving decision. One of the absolute cleverest parts of this whole setup is how it sees the world. It uses a special RGB infrared sensor. What that means is a single camera can see in full color during the day and then use infrared to see you perfectly in total darkness at night. It's a brilliant move that saves money and complexity because one sensor can do the entire job. So here's how that data journey works in 5 quick steps. First, the sensor grabs a high-res picture. Instantly, the chip's hardware splits that into color and infrared data. Next, our image expert, the VPAC, cleans it all up. Then, the AI genius takes over, analyzing the image to find your face, your eyes, maybe a phone in your hand. And finally, the system acts, maybe with a simple beep or a warning on the dash. So let's zoom in on that analyze step for a second, because this is really where the magic happens. The ability to make these split-second judgments comes from a seriously powerful, dedicated engine for deep learning. The AI accelerator on this chip can hit up to 2 TOPS. TOPS stands for tera operations per second. We're talking 2 trillion calculations every single second. That's the kind of massive firepower you need to run these complex AI models in real time with 0 lag. And to put that power into perspective, check this out. According to Texas Instruments, this specialized AI core gives you about a 50 times speed up compared to trying to run the same AI task on one of the general purpose cores. That's the difference between the system being fast and it being instantaneous.
Now, having a super powerful chip is one thing, but putting it in a car where safety is absolutely everything, well, that's a whole different ballgame. So let's look at how this tech is designed from the ground up to be incredibly reliable.
In the car world, you hear this term all the time, functional safety. It's all about making sure the electronics can't fail in a dangerous way. The AM62A chip is specifically built to help car makers meet a standard called ASIL-B, which is a non-negotiable must-have requirement for these kinds of safety systems.
A huge part of hitting that safety grade is this really clever design. The chip is basically split in two. You have the application domain, which runs stuff like your seat adjustments, but then you have the MCU safety domain, and it's completely walled off and isolated. This guarantees that some random bug in your radio software can never, ever mess with the critical safety monitoring. It's called freedom from interference, and it's a huge deal.
And of course, TI doesn't just throw this amazing chip over the wall and say, good luck. They give engineers a whole toolbox to work with. There's a hardware starter kit, software for any operating system, support for all the big AI frameworks, and even tools to make it easier to get the AI models onto the chip. It's the whole package, designed to get this tech into cars faster.
So at the end of the day, it all boils down to this. All that incredible complexity, the different cores, the insane AI speed, the safety firewalls, the software, it all comes together on one efficient little chip. And the result is a car that's just smarter, more aware, and fundamentally safer for you and everyone else on the road.
And this is just the beginning. It really makes you wonder, as our cars get better and better at seeing not just the road ahead, but us inside the car, what does that mean for the future of driving? What's next?